Hello, geometry students. This is Mrs. Myers here. We are starting a brand new module today. We're starting Mod 5, which is all about circles. So just a little word here, though. We meaning myself and Ms. McNamara, we spoke and we're rearranging the lesson just a little bit here. We're actually starting at the end of it because we feel like with having to condense this module anyway, that we might as well take from it what is most connected to what we have been working on. So again, we are starting with one of the end lessons, lesson 8. Okay, there are 2 days of it, day 1, day 2, because this is graphing circles on the coordinate plane and writing equations of circles from the coordinate plane, and we have just spent all of Mod 4 working on the coordinate plane. So we think that this is rather closely connected. So after we spend 2 days on this, we'll spend some days doing lessons from the beginning of the module, and unfortunately, we're not going to get to everything in the module that we would have liked to have gotten to, but we're, picking and choosing and doing what we think is most relevant to what we have already done and what you would need for the future. All right, so let's get started here. First of all, we are, we're writing an equation in terms of x and y, where you see some other variables here in the equation because, you want to think about what it is that defines a circle, okay? So a circle is a locus of points in a plane that is equidistant from a given point. So locus of points is really just a collection of points. So, so of course, what do we know about a circle? There's a center point, okay? That every point on the circle is the exact same distance from, and that distance is called the radius. Well, we've commonly used r for radius. I don't think that's a big deal, but now you can see that we've got h comma k as the center. So the equation of the circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So what you're going to be doing is you're going to be substituting in the values for the center of the circle, h and k, and you're going to be substituting in the value for the radius, which is r, and then that's it. You're leaving the equation in terms of x and y. I mean, that's what you always do. You always leave the equation in terms of x and y. I mean, when we dealt with, and you don't have to write this down, okay? But when we were writing the equation of a diagonal line, let's say in slope-intercept form, right? Y equals mx plus b. You substituted in something for the m, that was the slope. You substituted in something for the y-intercept, that was the b. And then, for example, you've got y equals negative 3/2 x plus 5, for example, right? That would be the equation of your line, because this is what you would have as all the collection of points, okay, that start at a y-intercept of 0, 5, and that have a change in y over change in x of negative 3/2. But, you leave the x and the y. So if you then wanted to check to see that you had, a proper point on this line, you would substitute in for x and y and see that it would fit the equation. So that's what we're doing here, okay? We're writing an equation of a circle this time though, right? And when it's in terms of x and y, you would then be able to say, all right, well, so if I think such and such point is a point on the circle, you could take your equation and you would substitute an x and y and you would actually see if it fits it, all right? So, let's get started with a few questions here. First, we are going to write the equation of the circle with center negative 1, 3 and radius 6, so very, very straightforward to start off with. Okay, we have this as h comma k since this is the center. Okay, so remember your center is always h comma k, and this is your radius, so this is your r. Okay, very, very straightforward right now. So I'm going to write the equation. Okay, let's just write it a few times in the beginning here just to get used to it. Okay, so x minus h quantity squared, so I say quantity because it must be in parentheses, plus y minus k quantity squared, again, must be in parentheses, equals r squared. So now I'm just going to substitute in the h and the k. So x minus h is negative 1, substitute that in. Okay, k is 3, so substitute that in. And r is 6, so substitute that in. Now, there's only a little bit of cleaning up that I can do here. First off, do the squaring of 6, that's 36. Then come here and look at what's inside the parentheses and see if we can clean this up at all. Well, this we can, because minusing of a negative, we know turns into plus the positive. So now this is x plus 1 quantity squared plus y minus 3 quantity squared equals 36, and you are done. Okay, that's it. That is the equation of the circle. All right, so let's get a little bit more. So second problem, again, straightforwardly, I'm giving you the center is 0, 4, so that's hk. I'm giving you the radius is square root of 3, so that's r. A little bit different numbers to work with from the previous problem. So let's write the equation, its general form again. Okay, now substitute in h and k. So x minus 0 quantity squared, y minus 4 quantity squared, and then square root of 3 squared. So is there anything that we can do to clean up inside the parentheses here and here? Yeah, because really, who goes around writing x minus 0? We're just going to write x squared, and then we don't need those parentheses because it's just x squared. Here's y minus 4 quantity squared, and this is square root of 3 squared, which is just plain old 3 because we know squaring and square root cancel out. Okay, and then that's it. This is the equation of the circle. Okay, don't go trying to expand it or do anything. Okay, leave it just like that. Okay, if you were to expand it, one of the most common errors is to just take y squared and negative 4 and square it and call it a day, but that is absolutely not what you would do. All right, so please don't go ahead and do that. If anything, y minus 4 quantity squared would be y minus 4 in parentheses times another y minus 4 in parentheses with all that distribution. Okay, so don't do that. Okay, just leave it like this. Okay, so how about if the center is 8, negative 5, and this time the diameter is 10? Okay, so what do we know about the diameter relating to the radius, right? We know the radius is half. So this means that r would be equal to 5. Okay, so keep that in mind. If the diameter is 10, now we know the radius is 5. All right, so we've got, I'll just maybe not write it one more time here. So x minus 8 quantity squared plus y minus negative 5 quantity squared is equal to 5 squared. So nothing to do with x minus 8 quantity squared, leave it. Here, the minusing of the negative turns into y plus 5 quantity squared, and then this 5 squared is 25. Okay, and then that is the end of that. All right, so let's work backwards here. Now, what if I give you the equation of the circle, and I want you to tell me what is the center and radius that we can actually graph it? Okay, so granted, it doesn't say state the center and radius, but if you were to graph it, that's what you need to know, is center and radius. So I'm going to just take this form and I'll line it right up. Okay, x minus h quantity squared plus y minus k quantity squared is equal to r squared. So here's this h lining up, but here's the thing when I'm going to circle, right? See, the positive 3 lines up with the minus h. Then I'm going to circle this. The negative 1 lines up with the minus k, and then the 9 lines up with the r squared. So we need to know the center, okay, which again is h comma k. We need to know the radius, which is the r. So if minus h is the same as plus 3, okay, then what is the h? Okay, what do you minus, okay, to get to positive 3? You would minus a negative 3. So that means the h is a negative 3. Okay, notice how that was the opposite of the plus 3, it's minus 3. But here, the minus k lines up with a minus 1. So you already got the subtraction from the negative here. That lines up. So that must mean that the k value is a 1. Okay, so now we are going to take a look at the radius. Okay, so we see r squared lines up with the 9. So if r squared matches up with 9, then we can square root each side, and r is 3. So let's come over to our graph, and we're going to plot the point negative 3, 1 for our center. And then we are going to graph a radius of 3. So now if I want to count boxes for 3 units, the only way I can do it is horizontally and vertically. Can't count diagonal boxes. Okay, so you can go right 3 boxes, there's a point on the circle. You can go up 3 boxes, there's a point on the circle. You can go down 3 boxes, there's a point in the circle. And I apologize for coming off the grid here, but you can go left 3 boxes, and that's a point in the circle. Okay, you can't count diagonally 3 boxes, all right? And then, of course, if you have a compass, go right ahead and use your compass to make for the nicest, most beautiful circle. Plus, I'm sure you miss using those compasses of yours. And there you have it. All right. So that's kind of the basic gist of it, but it gets a little bit more involved in this. So let's go to our next sheet of paper in our notes. Okay. Now we get to see those coordinate geometry formulas that we had used from the previous lessons in the previous module. All right, so we might potentially need to use the distance formula to find the length of the radius, and we might need to find the midpoint formula to find the center of the circle, okay? So it all depends on what the problem gives you. Sometimes there's a way around it, sometimes not. So let's take a look at our first one. If the center of the circle is given to you as negative 3, 6, and the radius has an endpoint at 0, 6, what would be the equation of the circle? So we know that that means x minus h quantity squared plus y minus k quantity squared is equal to r squared, right? That's the equation of the circle. We need to know h comma k and r. Well, this is h comma k. So how nice is that they gave you the center of the circle? So we just go x minus negative 3 quantity squared plus y minus 6 quantity squared. Okay, so we can clean that up. That's x plus 3 quantity squared plus y minus 6 quantity squared equals what, right? So what's the radius so that we know what the radius squared is? Well, it says that the radius has an endpoint of 0, 6. So what I would suggest you do is make a sketch for yourself. See what's going on with the diagram here, okay? So we have negative 3, 6, okay, which is right here. This is your center. I'm going to put a little c for center. And then the radius is an endpoint of 0, 6. Okay, so this is your radius. Now let's think about that, right? That's what the circle would look like then, right? So here's the center, right? Here's your radius. This is what the circle would look like. And it turns out that they were super, super nice and gave me the endpoint of the radius to be perfectly horizontal from the center. Now, as long as that given point is perfectly horizontal or perfectly vertical, okay, from the center, then your radius, again, is either a horizontal or a vertical line segment. You could just count boxes. So we can see clearly that this is just 3 boxes of length. So if the radius is 3, then I know I say equals 9 and I'm done. If you did not realize that, though, have no fear, okay? Or even if it's not a perfectly horizontal or vertical line segment, have no fear because we've got this distance formula right here, okay? So we can do that to find the length of that radius no matter what. So I would just basically take, this is x1, y1, for example, this is x2, y2, or vice versa, and just put it in. So I can go 0 minus negative 3 quantity squared, right? And then it would be 6 minus 6 quantity squared to follow. Minusing of the negative, this is 3 squared, this is 0 squared. So of course, square the numbers first, then add them together, and then what is the square root of 9? It happens to be 3, so of course I get the exact same answers when I just counted boxes. Again, it wasn't really necessary to do this because the radius was something that I could just count the boxes for, okay? But that's not always the case, so let's move on to our next example. So now we're going to write the equation of the circle with endpoints the diameter being 2, 7, and negative 6, 15. So making this quick little sketch here. Okay, and notice how high I'm going up with the y-axis here because I can see I have this y value of 17. So I've got 2, 7. Okay, that's 1 point. And then negative 6. And then 15. So is it 7, 8, 9, 10, 15. So there we go. So these 2 points are the endpoints of the diameter, right? So if I connect these, okay, that's your diameter. Okay, the whole thing is the diameter. So think about what we know for a circle, right? It needs a center and it needs a radius. The radius is half the diameter. So if I go straight across like that, that would be the diameter. So where is that center with respect to the endpoints of the diameter? It's exactly halfway, right? Now I'm just approximating this right now. I'm going to find it out exactly in a moment, okay? But this would be your center. Let's put a C there, okay? Then any, okay, segment that goes from the center of the circle, okay, to a point on the circle, meaning an endpoint of the diameter, would be your radius. So then this is what your circle would look like. So this would be one semicircle, half of the circle. This would be the other semicircle, the other half of the circle. I know that's not perfect, but that's the idea, okay? So I, first of all, need to find out where that center is. So I think I've got a pretty good idea from my sketch where it is, but let's just confirm it. Let's just do it algebraically. So this center is the halfway point between the endpoints of the diameter, right? That means it's the midpoint. So I'm going to use this right here, this formula for midpoint, right, to get the center. So this would be like x1, y1. This would be like your x2, y2. So off to the side here, I'm going to go center, and I'm just going to take 2 and negative 6. I'm just going to use the formula. See, add them together and divide by 2, right? And then 7 and 15 are your y1 and y2. Okay, and then add 2 and negative 6, which is negative 4. Add 7 and 15, which is 22. then do your divisions, and you get negative 2, 11. So if you think about plotting that point, right, negative 2, 11, yeah, it looks pretty good. Like, right, my calculation work matches my graph, so that's why it's always nice to do 2. So this is your center. So this is now your H comma K point, right? But I still need to get my radius. Now I cannot just count boxes like I was easily able to do before. Okay, this is a diagonal line segment, regardless of which one you're looking at. See, either of these segments from the center to the end point of the diameter would be the radius. Okay, they are diagonal segments. You cannot just count boxes there. All right, you need to use the distance formula. So now that I know that the midpoint between those two is negative 2, 11, right? So that's your center. You can take either pair, doesn't matter, okay? You can take either pair and you can get the radius. So I'm going to just take, for example, the 2, 7 and the negative 2, 11, and I'm just going to put them into the distance formula right here, okay? So 2, negative 2. So I go 2 minus negative 2, right? That's x2 minus x1 quantity squared. And then I've just got your, in the same order, 7 minus 11, okay, for y1 minus y2 quantity squared, or y2 minus y1 quantity squared. And then just do your calculation work. All right, so 4 squared, negative 4 squared, make sure you're keeping those parentheses, okay? Anything squared is positive as long as you got those parentheses there. Now do the adding together, and you don't have to simplify this. Don't turn it into a decimal, nothing like that, because remember, this is your radius, okay? There's your r value, and what we are now looking at, x minus h quantity squared plus y minus k quantity squared is equal to r squared. Okay, this is what you're going to put that r into. Okay, you're going to take that square root of 32 and you're going to square it. So don't even care about how there's a square root, because squaring and square rooting cancel each other out, and that's just plain old 32. Okay, so now I've got x minus negative 2 quantity squared. That's turned into x plus 2 quantity squared. Then I've got y minus 11 quantity squared. Then I'm going to add to x plus 2 quantity squared, and that just stays just like that. So there you go. There's your equation of your circle. All right. So as far as new information is concerned from this lesson, this is pretty much it. But now we've got some more practice problems. So maybe at this point, what you might want to do is try one of these additional extra practice problems from the classwork here on your own with the video paused. And then once you're done with the problem, play the video and see how you did on it. This will give you a good indication of how well you're understanding this before you go and do the problem set. Okay, so I'm just going to keep going through all the problems, and I'm going to do it a lot faster now that we've already kind of discussed all the material for this lesson. But you're welcome to, like I just said, pause the video as needed and try them on your own. Okay, so we've got the equation of the circle to write with the center at the origin. That's just 0, 0. So there's your h comma k. Okay. Diameter 5, meaning that the radius is 5 halves. Okay, half of that, I'd prefer to use fractions and decimals. So we go x minus h quantity squared plus y minus k quantity squared is equal to r squared. X minus 0 quantity squared, y minus 0 quantity squared, 5 halves squared. So this is just x squared, y squared is equal to 25 fourths, and that's it. Okay, again, I would prefer you to leave the fractions here as opposed to the decimals, and you don't need to write the minus zeros, so it's just x squared and y squared. All right, so one more page of some practice problems here. So we've got for ourselves the equation x squared plus y plus 1 quantity squared minus 4 equals 0. Well, that does not fit the bill of x minus h quantity squared plus y minus k quantity squared equals r squared just yet. I got a simple little adding of 4 to do to both sides. And now it's good to go, where my center, right, my h comma k, well, that h would be 0 since it's just plain old x squared. So nothing subtracted from it to make it x squared. And then the y plus 1 is y minus k. So that must mean that the k value is a negative 1. And then the radius, well, this is radius squared, so that's an easy 2. All right, so I plot the point 0, negative 1, that's my center. Radius is 2. I can only count boxes for horizontal and vertical line segments. So I go right to left 2, from the center, then I go up 2, down 2 from the center, and of course if you have a compass, go ahead and take your compass and make for a nice, beautiful little circle. All right, next, write the equation of the circle with the center to -4. So again, there's your h comma k, there's your center. Endpoint, meaning endpoint of the radius, sorry, or the diameter is 5, -2. So I do not have the radius just yet. This is my center, so I do have h comma k. So I can write x minus 2 quantity squared plus y minus -4 quantity squared equals something squared. So this is x minus 2 quantity squared plus y plus 4 quantity squared equals, but I don't know this radius yet. So I'm going to suggest we make a little sketch, see what's going on here. I always like the sketches, they can confirm our algebraic work as well. So 2, -4, okay, that would be your center. Let's put a C there. Endpoint of the radius slash diameter would be 5, -2. All right, so this would be your radius, and then that would make that be your circle about. It's not the best looking circle, but anyways, so I need to use the distance formula to get the length of this radius. Since it's not vertical or horizontal, count the boxes. So I'm going to just go square root of 5 minus 2 quantity squared, right? So here are my x's, and then that would make it -2 minus -4 for y2 minus y1 quantity squared. Anyway, go ahead and just do your calculations. You should be getting really good at this now. And square root of 13. Okay, so if we got the square root of 13 squared, then that's just plain old 13, and good to go with the equation. All right, very, very last one. Okay, let's see what's going on. Write the equation of the circle with the endpoints of the diameter being at -7, -2, and -15, 6. So I'm going to make a sketch here. All right. Again, I went really far out with my x-axis to the left because I see I got that -15, 6 to plot. So 1, 2, 3, 4, 5, 6, 7. Okay, so -7, -2, right? And then -15, so I'm at -7, 8, 9. Here's your -15 and then 6. Okay. So these 2 points here and here are the endpoints of the diameter, which would make like that be your circle. Okay, so what I need to write the equation of the circle, we've been doing this over and over again, is we need the center and we need the length of the radius. So the center is the midpoint of the 2 endpoints of the diameter, so we need to use the midpoint formula. All right, so go back and look it up if you don't remember it, but it's the averaging of these x coordinates, so -7 plus -15 divided by 2. The averaging of these y coordinates, -2 plus 6, right? Divided by 2, so go ahead and do your calculation work. Okay, and then there's your h comma k. All right, so there's your center. Okay, -11, 2. And now that we know where the center is, and look, that matches up perfectly fine. See, -11, 2, that was exactly what I thought it would be based on my sketch. Then you can use that center with either endpoint of the diameter to get your radius. So either use this pair or this pair, and then you can get your radius. Okay, so there's your distance formula to do that. So I'm just going to use -7 minus -11 quantity squared, and that would mean -2 minus 2 quantity squared. So go ahead and just do your calculations here. Again, you should be getting pretty good at using these formulas now, and stop right there. Okay, don't do anything further. No need to simplify that radical. No need to write it as a decimal. And we've got x minus -11 quantity squared, see x minus h quantity squared, plus y minus k quantity squared, y minus 2 quantity squared equals r squared. So x plus 11 quantity squared plus y minus 2 quantity squared is equal to just plain old 32, because squaring and square rooting cancel each other out. And then that is the equation of the circle. Okay, so I hope you have a decent understanding. now after all these practice problems for the equations of circles, and there will be a lesson 8 day 2 to follow this, which will still be on equations of circles, but the algebra will just be a little bit different. All right, please let me know if you have any questions, concerns, and I hope all is well. Have a good day.